Hello everyone, welcome to this module in which we are going to discuss about the edge services. Right. So what are the contents that we are going to cover in this particular module are we will be understanding about Route 53, we would be understanding about CloudFront and Outpost. Route 53 is the DNS service, that is domain name server service of AWS. This is very interesting service. The name also suggests here 53. We would be understanding why it is 53. And it provides or it is engineered for 100% availability. That is the highest for any of the AWS service. Next is CloudFront. So CloudFront is CDN service of AWS. What is CDN? CDN stands for Content Delivery Network. And lastly, we would be discussing about Outpost, which is yet another interesting service, which gives us the AWS capacities or AWS services on our premises. So they actually deliver one server or the entire server rack on premises for managing the AWS services from on-prem. Why it is required, what is the purpose of it, how we can configure it, we would be understanding here in this particular module. So let's get started with Route 53. So Route 53 is DNS, as I already told you. So what is DNS? We'll understand that first. How the DNS operates. What is Route 53? What are the core concepts of DNS, that is Route 53? What are record types and what are the different record types that are supported by Route 53? And what are the different routing policies that we can use with Route 53? So this is going to be a bit of theory part, okay? We won't be having demonstrations over here. We would be just looking at the theory for Route 53 and the CloudFront. So DNS stands for Domain Name System. What it is? It is a decentralized hierarchical naming system that translates domain name, which are human readable website addresses, to IP addresses. And vice versa is also possible. So we know that whenever we want to traverse our traffic on internet, we have to give the source address and we have to give the destination address. So generally what happens is any device on the internet communicates with each other on the basis of IP addresses. We understood the concept of IP address in the networking module as well. So these IP addresses are difficult to remember because those are numerical dot notations. Because we go to several websites nowadays, then remembering the IP address of each and every website is difficult. And that was IPv4. Till the time we are just using IPv4. But with IPv6, we have the longer notation, which is again difficult to remember. So that's why we have the domain names for the websites. So are those domain names just enough? So actually not. We just as a human being use those domain names, but internally it is being translated to the IP address. Even if we want to search for google.com, so we just go and type google.com. So Google has multiple IP addresses. Okay, the domain is google.com, but it is having multiple IP addresses because it operates on a large scale with multiple data centers and servers worldwide. So some of the IP address that Google uses is 216.58.194.174. Now, what you all can do is you can just copy this IP address and try to open this IP address and see if that works or not. Now, this may or may not work because it is worth noting that IP addresses change over the time. And Google may use different IP addresses for different service or applications. So if you need to find the current IP address associated with Google service for a specific Google service, you can just consult the documentation or support for perfect IP address. So that is about DNS. Now, if we see how the DNS works, then it is important to note that there are several steps included over here. So what will happen is, as I'm saying that the IP address, because it is difficult to remember, so we use the domain names. So what are domain names? These are domain names: www.google.com. Okay, so this is a domain name. Correct. So how the DNS will work? The user first of all will type the domain name into their web browser. It can be any domain. So when the domain name is hit, like when we just press the enter key, now this all things happen very quickly. We do not even understand that, any kind of lag is coming. So the domain name is typed into the web browser and the web browser will send the domain name system query to domain name resolver. So who provides this domain name? It is typically provided by our ISP, that is Internet Service Provider or public DNS provider. The query includes the domain name that user wants to particularly access. Now, what are the public domain name system providers? It can be Google or Cloudflare. So you might have seen many a times, right, that your browser check are done when you are accessing some of the websites. So at the bottom there would be written Cloudflare. So that is the public DNS provider. The third step includes the DNS resolver will check its cache. So the domain name is also basically, cached. So DNS resolver will check its cache to see if that IP address, if IP address associated with the domain name is already there in the cache. If it is, it will return the IP address to the web browser and the browser then can access using that particular IP address. But if DNS resolver will not have the IP address in the cache, then it will send the request to the root DNS server to find the authoritative DNS server for the top level domain. So top level domain means .com, .org, all of these are top level domain. Okay, now it is the last part of the domain name. So TLDs or top level domain are the highest level in the hierarchy of the domain name system. So these are used to categorize domain name into the group based on their purpose and the location. Okay, there are 3 levels of domain name: the top level, the second level, and the subdomain. Okay, so top level is com, we understood that. The second level is example. Okay, and the subdomain would be basically, if we have something like this blog.example.com. So this blog is subdomain. It is the prefix that comes before the second level domain. So these subdomains are used to create separate websites or to organize the content within the website. Overall, combination of these 3 levels of domain work together to create unique web addresses that allows user to access the websites on the internet. Right. The fifth step is if the cache is, if IP address is not found in the cache, we'll go to the root, we'll go to the authoritative DNS to find the top level domain. The root DNS server will be responding with the IP address of authoritative DNS server. For our case, it is .com. Okay, so managing top level domain is use of authoritative DNS server. The DNS resolver will then send a request to the authoritative DNS server for the .com top level domain to find the IP address associated with the requested domain, that is example.com. The next step would be the authoritative DNS server will check its record to find the IP address. If it has the IP address, it will return it back to the DNS resolver. But what if the authoritative DNS server does not have the IP address? Then it sends the request to the DNS server for the next level of the domain hierarchy, that is second level of domain. Okay, in this case, the DNS server for example.com to find the IP address. Now the DNS server for the example.com will check its record to find the IP address associated with it. If it has the IP address, it will return to the authoritative DNS, and authoritative DNS will send it to the DNS resolver. Okay, so authoritative DNS then returns the IP address to DNS resolver, which caches it for further request, and it will also return to the user's web browser. So the web browser uses that particular IP address which is being returned by DNS resolver, and it will connect to the web server that will be hosting the required website. The web server will be sending the requested page back to the user's web browser, which displays it to the user. So this is the entire flow of our DNS, that how it works. For simplifying this, we can also have a look at one image. Okay, so for that, let me take you to the whiteboard and we can just have one visualization of these 12 steps. Okay, so we are here on our whiteboard. So let us see how this will actually work. So first of all, what will happen? The client would be sending a request. Right, so I'll just put this as our client, let's say. Let's turn this around a little bit. Okay, the turning was actually not required. Let's just put it as it is. So this is our client, okay, which will send the request using the browser. Right. Now what will happen? The first thing, the request would be going our DNS resolver. So this is our DNS resolver. The next thing that will happen is it will check the details into the cache. Okay, but what if there are no details in the cache? Then we have to go in the backend for other servers. So let me just draw this over here, and then we can see what can be the entire process in the visual form. Okay. So what will happen over here? The client, this is our client. And what would be the client? Our browser. Browser will request, right, for any of the website. What is this then? This one is our root server. Okay, this is root name server. What is this? This one is top level domain name server. And lastly, what do we have? We have authoritative name server. Okay, so these are the different name servers that we have over here. So what will happen First of all, the request from the client would be going to our DNS resolver. DNS resolver checking the IP address into the cache. If the IP address associated with the requested domain is there in the cache or not. So if it is there for www.domain.com, then DNS will take the IP address and will return it back to the client. But if it is not in the cache, then what will happen? The DNS resolver will be contacting the root name server. Which root name server? The one with .com, because in our case we are having the top level domain as .com. Okay, just a minute. Yes, so it will say that it will ask root name server to search for the authoritative name server, right? So first it will go to the root name server. If the root name server is not having the authoritative name server's address, then what it will do is it will send the request. If it is there, it will return back to DNS resolver, and DNS resolver will give to client. If it is not there, then DNS resolver would be going to the TLD, that is top level domain name server, and it will say give me the authoritative name server for .com. If it is there, it will give it back. If it is not there, okay, then lastly the DNS resolver would be contact the authoritative name server with example.com, and it would be finding the result over there, and once the result or IP address is being found, it is delivered to the DNS resolver, and the DNS resolver would be taking it back to the client. So client browser would be taking that IP address, hitting that server, and resultant would be displayed on the client side. So this is what will happen into the entire process. Let's go through the steps one more time, and it would be much easier for you to remember and understand. So the first step over here is user will type the domain into the browser. The browser will send the DNS query to whom? To DNS resolver. It will check whether the IP is there in cache or not. Okay, if it is not there, then what we have to do? If the DNS resolver is not having the IP address in the cache, then the request would be sent to root DNS server. For what? To find the authoritative DNS server for top level domain, that is .com. Okay, so again, then root DNS server will respond with the IP address of authoritative DNS server for .com. Okay, so once it is found the IP address of authoritative domain name server, then the DNS resolver will send the request to authoritative DNS server for .com TLD to find the IP associated with the requested domain, that is example.com. Okay, then what will happen? The authoritative domain will check the record to find the IP address. If it has the IP address, it will return it. If the authoritative DNS is not having the IP address, it will send the request to the DNS server for the next level domain in the hierarchy, that is example. Okay, then the DNS server example.com will check its record to find the IP address, and if the IP address is found, it will be returned, and the authoritative DNS server will return it to the DNS resolver, and DNS resolver will send it to the web browser. So that is the entire process that we have over here. So now root 53. Why 53? Why not 59, 51, 63? There are so many numbers, right? That is because the DNS works on the port number 53. Ta-da! So that's why it is root 53. So root 53 is scalable and highly available domain name system web service, which is being provided by Amazon Web Service. It is engineered for 100% availability. So it allows the user to register your domain names. Like if you want to create your website, you have to get your domain name, right? So you can register it from here. You can manage your DNS records, that how your traffic is being routed, how the IP address would be translated. Okay. You can also configure the health checks to understand whether your environment is healthy or not, for which you want to send the traffic to. Then you have different routing policies as well. According to these policies, your traffic would be routed into your environment. It integrates with other AWS services like Elastic Load Balancer, CloudFront, AWS Certificate Manager for authenticity. Right. So this is our Route 53. Apart from this, there are some key features of Route 53 like global coverage. Obviously, it would be having the global coverage, right? Because it is our DNS server. So, Route 53 has a global network of DNS servers that can route traffic based on the location of the user, which provides low latency and high performance DNS resolution worldwide. So, your request can be coming from anywhere, and you will find Route 53 over there. The servers are there worldwide. Then the other feature is about traffic management. So Route 53 allows user to configure DNS based traffic routing policies such as weighted, round robin, latency based, geolocation. So we would be discussing about all of those traffic management policies, or say routing policies. Okay, we would be discussing that how they work. Then we have health checks. Right, we have already discussed here that we can configure the health checks. So you can monitor the health of the resources such as web servers or ELBs, that is elastic load balancers, and automatically route the traffic to the healthy resources in case of failures. So for that also we have one routing policy called as failover policy. We will be discussing about that. Lastly, the last feature that we'll be discussing is security. So Route 53 supports DNSSEC, that is Domain Name System Security Extension, which provides a way to cryptographically sign DNS records to prevent DNS spoofing attacks. Right. So overall, if we understand, DNS is a reliable and scalable DNS service that helps user to manage their domain name and route the traffic to their resources on the internet. The next topic is the DNS concepts. So what are the different DNS concepts that we have over here? So we have to understand about alias record, authoritative name server, CIDR block, DNS query, DNS resolver, the DNS actual thing, hosted zone, IP address, name servers, private DNS. So here, with the help of Route 53, you can have private hosted zone as well as the public hosted zone. So what are those? We would be understanding that. Then we will be understanding what is DNS record, what are the different types of it, routing policies, subdomain, and time to live. Now, out of all of this, we'll be discussing one by one over this slide itself, but DNS record and routing policy we would be discussing in depth. Okay, so let us try to understand these concepts about DNS. So the first concept that we want to discuss is the alias record. Okay, so what is this alias record? So it is a type of record that you create with Amazon Route 53 to route your traffic to AWS resources such as CloudFronts. Okay, you can go with CloudFront or S3, right? So this is the alias record. What are records we'll be understanding? Records, basically we have to create the records in DNS. Okay, it means that we have to tell that if this is the IP address, then where should I go? That mapping should be done by us, right? So we have to do that mapping, and for that we have different kind of records. So we would be talking about three different types of records in depth, but here we have also something extra, that is alias record. So let's say that if I have an IP address, okay, then if I want that IP address to be mapped with some domain name, then I create a type of record. But now what is alias record here is, it will directly allow you to uh, map your domain to the AWS resource. Okay, that resource can be anything, CloudFront distribution, ELB, S3. So unlike a standard record that contains an IP address, the alias would be actually pointing to the AWS record or AWS resource. And it is automatically updated by Route 53 when the IP address of the resource changes. This means that you don't need to manually update your DNS setting every time you make changes to your AWS resource. For example, let's say that you have a website hosted on the servers, right? EC2 instances, and you have Elastic Load Balancer in front of it. So you can create the alias record in Route 53 that maps your domain name. Let's say I'm having example.com. This is my domain name, right? www.example.com. So what will happen? You can map this example.com to the domain name or to the ELB's DNS. So we have the DNS of the ELB, right? How it looks like? It looks something like that. Suppose you have created ELB named as my ELB. So it would look something like this, my ELB with some, random ID associated with it. Then the region in which you have created, for example, US East 1. So it would be .US East 1 dot ELB dot Amazon AWS.com. So this is the DNS of ELB. Okay, so what will happen? The domain name of your website would be directly mapped to the ELB's domain name system. So this DNS for ELB will be automatically created when you create your ELB, right? So this is how the alias record will work. So it will map your domain name to the AWS resource instead of IP address. Right. So this was the first concept. Now let us just erase everything from the slide and see the next concept, that is authoritative name server. So we have already seen this authoritative name server in our how DNS works, but let's say a name server that has a definitive information about one part of domain name system and that responds to the request which is being given to it by DNS resolver. It is called as authoritative name server. For example, an authoritative name server for .com top level domain knows the name of the name servers for every registered .com domain. So when a .com authoritative name server receives a request from DNS resolver for, let's say, example.com, it responds with the name of name servers for DNS service for example.com domain. Okay. So that is our authoritative name server, which is also applicable in Route 53. Then we have the CIDR blocks. So we already know about CIDRs, right? So it is the IP range used with IP based routing. So in Route 53, you can specify the CIDR blocks from /0 to /24 subnet mask for IPv4. And for IPv6, you can give the net mask of /0 to /48. Right. So this is about CIDR. Then we have DNS query. So what is DNS query? Let's just erase everything here. Perfect. So DNS query usually a request that is submitted by a device such as computer or a smartphone to the DNS for a resource that is associated with the domain name. So that is called as DNS query. The most common example of DNS query is when user opens a browser, types the domain name in the address bar. So the response to the DNS query typically is the IP address which is associated with that particular website that we are trying to reach. The device that initiates the request uses the IP address to communicate with the resource. For example, a browser can use the IP address to get a web page from a web server. So whatever response is given back for the DNS query would be used for getting that particular response. Then we have the DNS resolver, the very first component which is checked for the IP address. So a DNS server, often it is managed by our ISP, Internet Service Provider, or Cloudflare or Domain or Google. Someone would be managing that DNS resolver, right? So that will act as an intermediary between the user request and the domain name server. So when you open a browser and enter the domain name in the address bar, your query first goes to the DNS resolver. The resolver will first of all check it into the cache. If it is not available, then it would be communicating with the root server and authoritative server and the name servers, right? Fine. The next topic or the next concept is DNS, Domain Name System. So it is a worldwide network of servers that helps computers, smartphones, tablets, and other IP-enabled devices to communicate with each other. So it helps us translate easily understood names such as example.com into the numbers known as IP addresses. Then we have hosted zones. So a container for record which includes information about how you want to route your traffic for a domain and all of its subdomain. That is called as hosted zone. So the hosted zone has the same name as the corresponding domain. For example, the hosted zone for example.com. Okay, if you are creating the hosted zone for example.com, it might include a record that has information about routing the traffic from www.example.com to a web server that has IP address, let's suppose 192.0.2.243, and a record that has information about routing email for example.com to two email servers like mail1.example.com and mail2.example.com. Email servers are also different and they require their own reports to be created. Right. So you would have noticed that when we join any of the company or firm, we get the email address of company, right? So it ends up with Amazon.com or say Google.com. If some employee is there, say Roy, and he is working in Google, so he might be having the address as Roy.com. Right. Then we have IP address. So IP address we already know, we will not discuss about this in depth. IP address is a number assigned to a device on internet. Anything, right? It can be a laptop, smartphone, web server. which will allow the device to communicate with other device on the internet. There are two types of IP addresses, IPv4, IPv6, right? We have already discussed about this. The next is name servers. So servers in the domain name system that help to translate domain names into IP address that computer uses to communicate with each other is called as name server. So here we can have authoritative name server, or we can have a, DNS resolver. All of these are the name servers. Then we have private DNS. So it is a local version of DNS that lets you route the traffic for a domain and its subdomain to Amazon EC2 instances within one or more VPCs. This would be basically into the private hosted zones. So as I told you that you can create two types of hosted zone. One is public, where you want to route the traffic in the internet, and one is private, which is private to your VPC. So in that case, you would be using the private DNS. Then we have records, or say DNS records. So it is an object in hosted zone that you use to define how you want to route your traffic for a particular domain or its subdomain. For example, you might create record for example.com and www.example.com that routes the traffic to a web server that has IP address something like 192.0.2.234. So it would be just like in a tabular manner. Okay, you have to create a record. You will say that this record is, let's say, A type record, where the domain name is example.com and the associated IP address would be 192.0.2.234, something like this. So you have to create these records for the routing information. Then we have the routing policies. So this will determine how Route 53 responds to your DNS queries. If you are hitting any of the particular domain name from your browser, then how to respond to it, how to route it. So there are different routing policies on which it is being understood that how to route it. Okay, so we would be discussing about this routing policies in our coming slides, so I'm not going in depth over here. Then we have subdomain. So it is a domain name that has one or more labels prepended to the registered domain name. Okay, so if you have example.com as your domain name, then www.example.com is your subdomain. If you create the hosted zone, other example can be if you create the hosted zone accounting.example.com. Okay. If this is the hosted zone, this is your domain name, right? Then New York dot accounting dot example.com would be your subdomain. Then there is TTL, that is time to live. So this is the amount of time in seconds basically that you want your DNS resolver to cache the value for a record before submitting another request to Route 53 to get the current value of the record. So if you want to cache the IP addresses, then you can do it using this TTL. Obviously, we cannot cache it forever because the IP addresses tend to change. So we don't want any stale or wrong information. So that's why we have to give TTL value. So if the query is coming to DNS resolver before the TTL expire, the resolver will return the cached value. But if the TTL is expired, then again it will follow that all the steps that we have already discussed. So the longer TTL will reduce your Route 53 charges. which are based in the part on the number of DNS queries that Route 53 responds to. A shorter detail reduces the amount of time that DNS resolver route traffic to older resources after you change the value in a record. Okay, so both are having pros and cons. So you have to take care while defining the TTL value carefully. How frequently you are going to change your IP address in the records, that you have to be deciding before you have to set the TTL value. So these were the different concepts of DNS or Route 53. Now we have different record types over here. So these are all the different record types which are being supported by Route 53. Are we going to discuss all of these? No, we are not going to discuss all of these. Okay, we would be discussing about few of them, especially quadruple A and CNAME. Okay, so these are all the different record types which are supported, but let's just go to A, quadruple A and CNAME. And before to that, we will just understand what all these stands for. Okay. So A record stands for address record. Okay, this is address record. This is also address record, but it is for IPv6. Then we have CAA, that stands for Certification Authority Authorization. Then we have CNAME. CNAME is Canonical Name Record. Okay. Then we have, we'll see DS as well. We have MX. So MX basically is for mail exchange. Then we have NAPTER. This is for name authority pointer record. We have NS for name server. We have PTR. PTR is for pointer record. We have SOA, that is start of authority record. So start of authority record is by default created when you create your hosted zones. Then we have SPF, that is sender, it is sender policy framework. Then we have SRV. SRV stands for service locator. And lastly, TXT would be text record. So these are all the different types of records that we have into Route 53. These are all the supported types. And one is left over here, that is DS. The DS actually stands for Delegation Signer. Okay. So this is basically used when you want to establish a chain of trust when you are configuring DNSSEC signing. What was this DNSSEC signing? We discussed about the security feature of Route 53. So at that time we understood that it cryptographically signs a record. Right. So that is the record for signing that particular thing. Okay. So these are all the records. Now let us see the first record, that is our A type of record. So A record is used to route the traffic to a resource such as web server using IPv4 address. So I can say that I'm creating a record for example.com and it should be mapped to one IP address. Something like this. Then you can have for a record for IPv6 addresses. Okay, so that's the difference. A record for IPv4, 4A for IPv6. Then we have the CNAME record. So what it will do is, it will map the DNS queries for the name of current record, such as acme.example.com to another domain or subdomain. So here we have taken the example. A record is having this @ and it is having IP value this. Now CNAME, which might be having www dot something. So that would be mapped to another record that is already created. So it is mapped to this @ and @ is already created with the A record. So it will be pointing to this A record and then it would be fetching the IP address from there. It is kind of chaining. Okay. Fine. Then the next example or the next topic is routing policies. So there are all of these routing policies possible: simple, failover, geolocation, geoproximity, latency based, multi-value answer, and weighted. So all of these are the routing policies of AWS, Route 53. So if we go and understand the simple routing policy, then this lets you configure standard DNS record with no special Route 53 routing. So you will typically route your traffic to a single record, for example, to a web server of your website. So it is commonly used for the resources that are not replicated across regions or data centers. It is just used for single resource. So you can use this simple routing policy for the records in your private hosted zone. If you choose the simple routing policy in Route 53 console, you can't create multiple records that have same name and type. But you can specify multiple values in the same record, such as multiple IP addresses. So this was the simple routing policy. Then we have failover routing policy. So this routing policy lets you route the traffic to a resource when a resource is healthy, or to a different resource when the first resource becomes unhealthy. Okay, so this will always ensure that our traffic is being redirected to our healthy instances instead of unhealthy instances. So how this would look like? So I have one diagram for this, and this diagram is something like this. Suppose I have my Route 53 over here. Okay, and I have my workload running in, let's say, US East 1. Here I have my ELB, and the ELB is connected to the backend auto scaling group. I have another environment which is running in US East 2. I have my ELB, and this ELB is sending the traffic to auto scaling group in the backend. So let's suppose that Route 53 is sending the traffic and this environment is failed. Okay, it sends the traffic generally to both of the environment, but if one of the environment is failed, then what will happen? The traffic would be just routed to the healthy environment. So by that, your customers won't be suffering, right? So this is about the failover routing policy. Then we have geolocation routing policy. So it allows you to route the traffic based on the location of your users. Suppose you want that the users from Europe, okay, all the DNS queries originate from Europe should be routed to the elastic load balancer in Frankfurt region. And all the DNS queries created from USA should be going to the North Virginia region. So this is where you can use the geolocation routing. So with this, you can localize your content and present some or all of your website in the language of your users. You can use this geolocation routing to restrict the distribution of content to only the location in which you have distribution rights. So how this would look like? It would look something like this. Let's say I am having my route 53 over here, right? We have two queries coming in. The first query is from USA, another query is from Europe. Okay, then what will happen over here is I have two environments running. The first environment is in US East 1 and the other environment is in EU West 2, let's say. Okay, so here the request coming from the USA person, let me just change the color of Europe. Okay, the request coming from the Europe would be going to the Europe region. And the request coming from the USA would be going to the workload running in the USA region. So you can set the appropriate records based on the user's location and you can leverage this geolocation routing policy. Then the next type of policy that we have is geo proximity. So as the name is suggesting, geo proximity routing lets Route 53 route your traffic based on the geographical location of your users and resources. Basically, this will be routing the traffic to their nearest point. Okay, you can optionally choose to route more or less traffic to a given resource by specifying the value called as bias. So a bias expands or shrink the size of geographical region from which the traffic is routed to a resource. Okay, for example, we have the entire world map. Okay, here there is some, North America, let's say North America, then we have South America over here, right? We have the entire Africa and then we have the Europe and the Asia region over here, right? So this is the entire world map, let's suppose. So I'll say that my one environment is created over here, my one environment is created somewhere over here, other environment is created here, one environment created here and here. So I can decide that the request coming from the user across the world, where to put those requests. Okay, I'm having users all over the world. So where to put those requests? So according to this, nearest point, it will go to the nearest point, but you can specify the bias value. And you can increase or shrink the size of geographical region. For example, this is one geographical region. Then we have this geographical region. Okay, this much. Then we have this geographical region like this. We have this geographical region. Now what will happen in this particular case? All the requests generated by these two users would be going to into the region where they are. The user generating traffic from here would be going to this particular environment. Okay, these three users would be going to this environment. This both users will go to this, and these two users will go here. So you can change the geographical region size. So this is the size of geographical region based on the bias value. If you increase it, your expand your geographical region would be expanded. So maybe if I increase it, it will become this. Okay. So you can just point your user's request to this environment itself, and you can reduce this environment from here if you want. So that is geo proximity routing policy. Then we have latency based routing policy. So what happens into latency based, as the name is suggesting, this will provide lowest latency based on the geographical location of the user. It will measure the latency between user's DNS resolver and the resource IP address and will select the resource with the lowest latency possible. Okay. So again, what will happen over here is we have one diagram that we can use for understanding it better. We have Route 53 with us as always. Okay, we have two regions in which our workload is running. Let's say one is US East 1, another one is EU West 1. Okay, so here to this particular environment, when the user is submitting the request, it is 76 milliseconds of latency, and to this environment it is 138 milliseconds of latency. Then what will happen here is Route 53 would be redirecting the request to this particular environment because that would be giving lowest latency possible to us. Right. So that is latency based routing policy. Lastly, we have multi-value answer routing policy. So into this, what happens is we can actually configure Route 53 to return multiple values such as IP addresses for your web browsers in response to DNS queries. So you can specify multiple values for almost any record. But multi-value answer routing also lets you check the health of each resource. So Route 53 returns only the values for a healthy resource. So here what will happen is only the resources which are healthy, you would be sending the traffic to that. So this can be useful for load balancing the traffic across multiple resources, though it is not the substitute for a load balancer, but the ability to return multiple health checkable IP address is a way to use DNS to improve the availability and load balancing. So for one resource, you would be having multiple IP addresses here. The last type of routing policy is weighted routing policy. So to improve the environment that you have, you might be changing something, right? You can create new environment for, let's say, a feature got added or a bug got fixed. So in that we have created a new environment. So what this weighted routing policy will do is it will allow you to associate multiple resources with a single domain name or subdomain. And you will be choosing that how much traffic is routed to each resource. So this can be useful for a variety of purposes, including load balancing and testing new versions of your software. Okay, so let's suppose that I have this already environment in production. Okay, but I have added some new features and I have this environment production new. So I cannot directly route all my traffic to this new production environment. What if it fails? What if it has bugs? Then what I can do is I can just have the weighted routing policy stating that 80% of traffic would be routed to production and 20% would be going to production new. If everything works fine over here in production new, then we can shift our entire traffic to production new and discard this production. So this was the last type of routing policy that we have.